Namaste. Maps are like stories of our world. They show countries, oceans, and places we live. Cartography means the art and science of making these maps. With maps, we understand distance, direction, and location, helping us to explore, travel, and connect better with our planet. Maps help us to see and understand the world around us. They guide us, explain places, and help to connect people. The word map comes from Latin word mappi or mappi, which meant napkin, cloth, or a sheet. So, because early maps were often drawn on such simple materials. Long ago, in 6th century BC, a Greek philosopher named Anaximander created one of the earliest known maps of the world, trying to show the entire earth as a whole. His work was an important step toward what we today call cartography, the art and science of making maps. Early maps were not perfect or exact, but they reflected how people imagine and understand the world at the time. From those beginnings on clothes to the digital maps on our phones today, maps tell the story of human curiosity and our need to explore, share, and organize knowledge about our planet. A map is a two-dimensional drawing of the Earth's surface. It is made to scale, which means distances are shown in the right proportion. Maps use colors, symbols, and labels to represent features, making them too easy to read and understand. With a map, we can see mountains, rivers, forest, and vegetation cover, as well as towns, roads, and other man-made features. Many maps also show terrains and heights, helping us to know how the land rises and falls. For example, a political map of India show all the states and union territories along with their boundaries and capitals. This helps us to understand how the country is organized. India has 28 states and 8 union territories, each with its own culture and identity, and maps make this diversity clear at a glance. Maps are therefore much more than just drawings. They are tools that help us to learn direction, distances, and landmarks, and the relationship between places. Maps are most important because they help us to find locations, guide us in navigation, and allow us to plan activities. Suppose you want to guide a friend to your school or a park, you could draw a simple route map with landmarks in like temples or a road or a shop, and your friend could simply follow it. In the same way, maps show us where things are and how to reach that place. They also help us to choose shortest path by showing distances. Maps are not just useful for travel, they are also important for planning. For example, before building a road or a bridge, government authorities use maps to see existing buildings, rivers, and other features in that area. Every map has symbols to represent information. Points mark small things like wells or houses. Lines show features like rivers or roads. Polygons mark larger areas such as forests or cities, and text gives their names. Together, these elements make a map a powerful tool to understand, organize, and plan our world. On a map, directions are shown with north-south line, where north usually has an arrowhead and a short cross line marks east and west. These are the main directions: north, south, east, and west. Between them, we get northeast, southeast, southwest, and northwest. Now imagine a school at the center of our map. To the north, there are hills. In the northeast, a village. Moving around clockwise, you find the panchayat office in the east, then a bus stop in the southeast. Right to south is the rice mill, and in the southwest stands a hospital. On the west side, we see a theater, while in the northwest there is a pond. Directions help us to place landmarks correctly and read maps with confidence. That is why physical maps have a north arrow and digital maps use compass to guide us clearly. Map symbols are used to show real-world objects like buildings, roads, or rivers on a paper. Without these symbols, maps would be confusing. The Survey of India, a premier mapping agency in India, makes many maps and includes keys or legends, which are small boxes explaining what each symbol means. If you only see a sign or shape on the map, you don't understand it. You just need to check the legend. So it acts like a directory for the map. Both shapes and colors are used, so making it easier to recognize places and features quickly, helping everyone to read and use maps correctly. Cartography comes from two Greek words, chartis meaning map and graphos meaning to draw or write. It is the art and science of making maps done by experts called cartographers. Humans have drawn maps for thousands of years to understand their environment. The oldest known maps in India date back to Bronze Age, with early civilizations like Indus Valley creating drawings to represent land and stars. Long ago, maps were drawn by hand with limited information and often showed locations relative to something else. Today, cartographers use modern tools like GIS and geographical coordinates like latitude and longitudes to make map more accurate. These tools help us to see the world clearly and navigate it better. A map is like a picture of the Earth's surface, but drawn much smaller so we can see it on a paper. The key to this is something called scale or map scale, defined as a ratio or representative fraction. It tells us how the distance on map compares to real world distance. For example, 1 centimeter on the map might mean 50,000 centimeter on the ground or half a kilometer on the ground. If we try to draw a city or a country of full size, it would be impossible on a sheet of paper. So scale helps us to shrink it down. So when we look at a map, things to notice is the scale. You will often see it on this small box called scale bar at the corner of the map. The scale tells us how the distance on map compares to real world distance. Different countries use different units like miles or kilometers, but the idea remains same. Now the scale can be shown in three different ways. One is the simple statement, for example, 1 centimeter equal to 0.5 kilometers. That means if you take a ruler and measure 1 centimeter on the map, it usually represents half a kilometer on the ground. Another way is the representative fraction or RF, which is written as ratio like 1 is to 50,000. So this means one unit on a map equal to 50,000 of the same unit in reality. For instance, imagine a village with representative fraction or scale 1 is to 50,000. If the distance between a temple and school is 1 centimeter on map as shown here, then the real life distance is about 50,000 centimeters, which converts to 500 meters or half a kilometer. So what seems tiny on paper actually covers a big distance on the ground. That is the magic of this concept of scale, and it helps us to read the maps accurately. Here you can see what we call graphical or linear scale. It is one of the easiest way to read distance on a map. Think of it as like a ruler. Think of it as like a ruler drawn on the map itself. Each section of the bar stands for a real distance on the ground. For example, on the top scale, 1 centimeter equal to 40 kilometers. The beauty is if the map gets bigger or smaller, the scale bar changes with it, so it still works. Now look at the second example. It shows the scale of 1 is to 50,000. That means 1 centimeter on the map equal to 50,000 centimeters or 500 meters in real life. The bar is marked in small steps of 500 meters and larger steps up to 3 kilometers. This makes measuring short and long distances quick, clear and accurate. No tough math required. Let us clarify a common point of confusion, the difference between small scale and large scale map. A small scale map like 1 is to 1 lakh or 100,000 covers big area but with lesser details. So it might show an entire city with only main roads, rivers or boundaries. A larger scale map like 1 is to 5,000 zooms in on much smaller area such as a city block, or here you can clearly see streets, buildings or finer features. If you look at the graphics, notice how small scale map looks zoomed out while large scale maps feels closer up. Understanding this difference is important because it helps us to pick the right map, whether you need a broader overview of the region or detailed guide to navigate specific locations. Here we have the idea or demonstration of dynamic scale in Geographic Information System or GIS. Dynamic scale simply means that the scale of the map changes automatically as you zoom in or zoom out. This is something you often see in an interactive maps like the Bharat Map portal or Google Maps in your mobile phones. For example, when you look at the Delhi from broader view, the map only shows the big features such as major roads or city boundaries. But when you zoom closer, the scale adjusts and you can see much more detail like smaller streets, parks, or landmarks. Notice in the graphics how the level of detail increases with zoom level, that is the dynamic scale at work. This makes map easier to use because the information shown always matches this level of zoom. It helps user to measure distances, understand locations, and also navigate smoothly without needing to manually adjust and relocate. Dynamic scaling is what makes modern GIS maps are so flexible and user friendly. Now let us look at the list of different types of map shown on this slide, from topographic maps to meteorological maps. Each type tells a different story about the earth, and as we go along we'll explore what they show and how they are useful. A topographic map is a special kind of map that shows both natural and man-made features on the ground with greater detail. So these maps includes things like hills, rivers, forest, farmland, settlements, and even transportation networks. They are sometimes called general purpose maps because they cover so many features. Topographic maps are usually made at large scales and officially prepared by national mapping organizations for each country. For example, in India, the Survey of India produces them for the whole country. To keep things consistent, these maps are created in series, which means uh, they use the same scale, symbols, or colors and projection. Now, if you look at the graphic on the slide, you can see a national level topographic map with color shadings to show elevations. Notice how the green areas along the coast of Gujarat and Bengal mark land below 200 meters. While central India rises between 1000 to 2000 meters, the Himalayan region you can see shoots up to more than 4000 meters. This way, a single map gives us a clear picture of landforms, height differences, and major features at a glance. Contours are special lines that you will see on topographic maps that helps us to understand shape of the land. Each contour line connects points that at each contour line connects points that are at the same height above sea level. So when you look at the left graphic here, you will see how the lines from loops are at different level, showing a hill getting higher as we move inwards. The photo in the middle shows a real landscape with sloping sides that match the way contour appear on a map. The colorful map on the right side uses contour lines and color to show hills and valleys clearly, helping us to imagine the land in 3 dimensions. By following the spacing and shape of these lines, we can tell if the ground is steep or flat or has some sudden drops. A contour map shows lines called contours. So each of these lines joins places that are at the same height or elevation above sea level. The number written on the lines tells us the exact elevation. On the picture here, you can see how the lines are closer together on steeper slopes and wider apart on gentler slopes. If you look at hilly area, the contour might show the land rising from 400 to 500 meters. So these patterns helps us to understand shape of the land from valleys to peaks without actually being there. A topographic map is made up of many small elements that together gives us a clear picture of the land. This includes natural features like rivers, lakes, forest, hills, slopes, and valleys, along with human-made features such as roads, railways, power lines, and settlements. On the graphics, you will notice that each feature is shown using special symbols or colors. For example, blue usually represents water, green is shown for forest, and brown often shows elevation or relief. These symbols are explained in the legend, which acts as a guide to read map correctly. The map also shows scale, which helps us to measure real distances on the ground, and grids of latitude and longitude, which help us to locate exact locations. So if you look closely at the graphic, We'll also see title on the map, which is printed at the corners, and north direction is also at the top. By combining all these elements, a topographic map becomes like a detailed language of the land, where every color, line, and symbol tells us something specific about the place. Next is a cadastral map. A cadastral map is very detailed map that shows the boundaries and ownership of land parcels. It usually contains dimensions, area, and direction of each plot, making it an important tool for recording who owns the piece of land and how it is used. These maps are created through cadastral surveying, where licensed surveyor measure land boundaries using legal documents and fieldwork to ensure accuracy. Cadastral maps are widely used in property transactions, urban planning, and land management. They help to establish property titles, calculate land values for taxes, and even resolve disputes about boundaries or ownership rights. If you look at the graphics on the side, you will see how each land parcel is drawn with the clear divisions showing exactly where one plot ends and another begins. In India, such maps are known as Bhunaksha, and they are maintained by government of both state and national levels. Physical maps show us natural face of the earth, mountains, valleys, rivers, lakes, and many other landforms. Unlike political maps that mark borders and cities, these maps focus on geography and shape of the land. You will notice colors and shading that makes the terrain easier to imagine. Blue usually shows water, green means lower areas, brown and gray points to higher mountains. These maps are made using aerial photos or satellites or surveys on the ground. Cartographers, the people who draw maps, use clever tricks to turn 3D landscapes into flat images or maps. Physical maps are very useful for students, etc. They use them to learn. Hikers and campers use them to plan safer routes. Scientists and planners study them to understand land and resources. In India, they help to explain everything from tall Himalayas to wider coastal plains. Political maps show us the human side of geography. They mark countries, states, cities, and borders instead of mountains or rivers. These maps use bright colors, clear labels, and symbols so we can easily tell one region from another. To make them, cartographers collect information from surveys, census reports, and government records, turn them into visual picture. Political maps can be very large, showing the whole world, or very detailed, showing a single city. They are important tools in classrooms where students learn about regions and territories, and also in government planning, resource management, and even elections. In India, these maps help to explain many states, union territories, and major cities. They are updated often to show changes in boundaries or governance. In short, political maps gives us clear picture of how people organize and manage space on our motherland. Thematic map focus on one specific theme like population or climate or land use, etc. Instead of showing all features like regular maps, thematic maps use colors, symbols, and shading to make patterns easy to see and understand. For example, a land use map of India shows how land is used in different regions, maybe for farming, industry, or cities, forest, or barren areas, etc. To make these maps, experts collect data from satellites and field surveys and then analyze it to show patterns clearly. These maps are very useful for planning cities, building infrastructure, and managing resources. They also helps us to track changes over time like urban growth or farming expansion. In short, thematic maps gives a focused view of how land and other resources are used. Meteorological maps show the weather and atmosphere over a region. Things like temperature, rainfall, wind, and air pressure. They help meteorologists and researchers to understand weather trends and predict future conditions. There are different types of maps. For example, a cloud map of India uses satellite derived data to show where clouds are and how dense they are. So, this helps people to quickly see current weather conditions and track storms or rain. Meteorological maps are powerful tools for studying climate and early warning systems. Map elements are like basic parts that makes any map easy to read and understand. The legend explains symbols or colors so we know what each one means. The north arrow shows direction, helping us to figure out which way is the north. The scale tells us how map distance relate to real distance so we can measure it correctly. While the projection shows how Earth's curved surface is drawn flat, we will learn more about it in a later video. The source tells us where the map data come from, which helps us to trust its accuracy, and title quickly tells us what the map is all about. Put together, all these elements make map clear, reliable, and useful. When we use online maps or GIS portals, unlike old-fashioned paper maps, they are not just pictures. We can zoom in and zoom out to see the any place we want. We can even change the base map, like looking at satellite imagery, terrain, or city layouts. These maps lets us add layers like roads, railways, or administrative boundaries so that we can see more than just the surface. You can also plan routes or get directions between 2 points. They are super handy for exploring or studying places. We can also measure distances or areas and even create elevation profiles to understand hills and mountains. Plus, points of interest pop up so we find where are the schools or parks or other landmarks. All these tools makes maps interactive and helps us to study the world in a ways paper maps never could. A coordinate system helps us to describe the exact location of any place on the earth, just like giving an address. So you see X, Y, and Z coordinates that are marked, making it easy to find positions anywhere on the planet. There are two types of coordinate systems used in maps: geographic coordinate system and projected coordinate system. We will explore how this geographic coordinate system works to show our place on Earth using known references like equator or North Pole. The geographic coordinate system is one of the most common ways to locate any places on the Earth. It uses numbers called latitude and longitude, and sometimes height value also. It describes any position on the surface. Imagine the Earth covered with invisible lines. The horizontal lines are latitudes and vertical lines are longitudes. Geographers choose the equator as starting point for latitude. They choose the prime meridian as starting point for longitude. Latitudes are measured north or south of the equator. Longitude are measured east or west of the prime meridian. So if you know latitude and longitude, you can point to any exact location on Earth. Think of it as like a unique address for every spot on the globe. This helps scientists, explorers, and even your phone maps to find places quickly and accurately. The geographic coordinate system is a global way to find exact location on Earth using two values, latitude and longitude. Imagine the Earth wrapped in an invisible grid, making of lines that cross each other. These lines help us to pinpoint any spot with precision. Latitude lines run horizontally like rings around the Earth. They measure how far north or south a place from equator, which is set at 0 degrees. The equator divides the planet into northern and southern hemispheres. Latitudes range from 0 degree at the equator up to 90 degree at the poles, and they often called parallels. Longitude lines, on the other hand, run vertically from North Pole to South Pole. They measure how far east or west we are from prime meridian, which is at 0 degrees in Greenwich, England. Longitude ranges from 0 to 180 degree east and 0 to 180 degree west. Together, latitude and longitude form a unique pair of coordinates, and with these, we can describe any location on Earth, just like giving it a precise address. This example demonstrates how to use latitude and longitude coordinates to pinpoint a specific location. This case is somewhere in India. So these coordinates are expressed using degrees, minutes, and seconds for both latitude and longitude. Latitude indicates a location position north or south of the equator. In this example, the place is situated 26 degrees, 47 minutes and 44 seconds north of the equator. Longitude, on the other hand, determines a location's position east or west of the prime meridian. Here the location lies 82 degrees, 11 minutes and 40 seconds east of the prime meridian. By inputting these coordinates into a mapping services like Google Maps, you can accurately locate the specific place on the map. This can be a valuable tool for exploring unfamiliar areas or simply understanding the geographical position of a particular point on the earth. I encourage you to try locating this place on Google Map yourself and see you can discover any interesting facts or significance about it. Moving on, image interpretation is the process of analyzing and extracting meaningful information from images typically obtained from remote sensing platforms like satellites. It involves identifying, classifying, and understanding features or patterns in the images, such as land cover or vegetation, water bodies, urban infrastructure, or even geological formations. This process combines visual examination using human perception and expertise and automated techniques such as machine learning algorithms to derive insights. Image interpretation is widely applied in fields like environmental monitoring, urban planning, agriculture, disaster management, and military reconnaissance. Its accuracy depends on resolution, spectral information, and interpreter's skill. So we will learn more about it in later videos. Interpreting satellite images in remote sensing can be tricky because it involves looking at pictures of Earth taken from space and figuring it out what they show. These challenges arise from several reasons. First, the images are made up of tiny squares called pixels, and each pixel might contain information about multiple things like trees, buildings, or water. This makes it hard to tell what is there. Second, clouds, fogs, or smoke in the atmosphere can block the view, making the smaller areas unclear or even invisible. Another issue is that some things look very familiar in satellite images. For example, dry soil and certain urban areas appear similar, so it's easy to mix them up. On the top of that, changes in sunlight, shadows, or seasons can make the same place look different in different pictures. The size of the image is also a challenge. Satellite images can cover huge areas, so analyzing them requires time, expertise, and sometimes powerful computers. To make sense of these images, experts use special techniques and tools, but it still requires a mix of science, technology, and experience to get accurate results. The image here depicts portion of a lake, an urban area in Tamil Nadu state in India. It is also quite challenging to clearly distinguish the lake's boundaries from this picture. Further zooming in is not useful because image resolution is limited. So therefore, interpreting satellite images often proves to be complex and demanding task. The kind of information we get depends on a lot of knowledge and skill of the person who is analyzing the image. Sometimes one clue is enough to identify something, but often we need to combine many clues. These clues or elements include things like color, tone, size, shape, texture, and pattern. We also look at shadows, height or depth, and the location of objects and how they related to what is around them. By carefully putting these pieces together, we can recognize features like rivers, forests, or buildings or roads, etc. This skill is very important for remote sensing because it helps us to turn raw images into useful knowledge. We'll explore these elements in more details and practice them in a later video. That is the end of this video. Thanks for watching. Namaste.